Hello everyone. Today we are going to read chapter 12, Some Natural Phenomena. This chapter is a long chapter, so we are going to read it in two parts. Today we are going to read the first part of it. In this chapter, we shall discuss two destructive natural phenomena. These are lightning and earthquakes. We shall also discuss what steps we can take to minimize destruction caused by this phenomena. Lightning. You might have seen sparks on an electric pole when wires become loose. This phenomenon is quite common when wind is blowing and shaking the wires. You might also have seen sparks when a plug is loose in its socket. Lightning is also an electric spark but on a huge scale. In ancient times, people did not understand the cause of these sparks. They were therefore afraid of lightning and thought that the wrath of God was visiting them. Now, of course, we understand that lightning is caused by the accumulation of charges in the clouds. We need not be afraid of lightning, but we have to take precautions to protect ourselves from the deadly sparks. The sparks that the Greek knew about. The ancient Greeks knew as early as 600 BC that when amber is a kind of resin, was rubbed with fur, it attracted light objects such as hair. You might have seen that when you take off woolen or polyester cloths, your hair stands on end. If you take off these cloths in the dark, you even see a spark and hear a crackling sound. In 1752, Benjamin Franklin, an American scientist, showed that lightning and the spark from your clothes are essentially the same phenomena. However, it took 2000 years for this realization to occur. I wonder why they took so many years to realize the similarity. Scientific discoveries are a result of hard work by many people. It can sometimes take a long time. We shall now study some properties of electric charges. We shall also see how they are related to the lightning in the sky. Let us perform some activities to understand the nature of electric charges. But recall first that what you might have played as a game. When you rub a plastic scale on your dry hair, the scale can attract very small pieces of paper. Charging by rubbing. Activity 12.1. Take a used ball pen refill and rub it vigorously with a piece of polythene. Bring it close to small pieces of paper. Take care not to touch the rubbed end of the refill with your hand or with a metallic object. Repeat the activity with small pieces of dry leaf, husk and mustard seeds. Record your observations. When a plastic refill is rubbed with polythene, it acquires a small electric charge. Similarly, when a plastic comb is rubbed with dry hair, it acquires a small charge. These objects are called charged objects. In the process of charging, the refill and the plastic comb, polythene and hair also get charged. Let's try to charge some other objects that are familiar to you. Activity 12.2. Collect the objects and the materials listed in table 12.1. Try to charge each by rubbing with the materials mentioned in the table. Record your findings. You can add more items to the table. You can collect objects like refill, balloon, eraser, steel spoon, and the materials you can use for rubbing are polythene, woolen cloth, dry hair, wool, etc. Types of charges and their interaction. We will select some objects from table 12.1 for the next activity. Activity 12.3. Inflate two balloons, hang them in such a way that do not touch each other. Rub both the balloons with a woolen cloth and release them. What do you observe? Now let us repeat this activity with the used pen refills. Rub one refill with polythene. Place it carefully in a glass tumbler using the tumbler as a stand. Rub the other refill also with polythene. Bring it close to the charged refill. Be careful not to touch the charged end with your hand. Is there any effect on the refill in the tumbler? Do the two attract each other or repel each other? In this activity, we have brought close together the charged objects that were made of the same material. What happens if two charged objects made of different materials are brought close to each other? Let's find out. Rub a refill and place it gently in a glass tumbler as before. Bring an inflated charged balloon near the refill and observe. Let's summarize the observations. A charged balloon repelled a charged balloon. A charged refill repelled a charged refill. But a charged balloon attracted a charged refill. Does it indicate that the charge on the balloon is of a different kind from the charge on the refill? Can we say then that there are two kinds of charges? Can we also say that the charges of the same kind repel each other while charges of different kind attract each other? It is a convention to call the charge acquired by a glass rod when it is rubbed with silk as positive. The other kind of charge is said to be negative. It is observed that when a charged glass rod is brought near a charged plastic straw rubbed with polythene, there is attraction between the two. What do you think would be the kind of charge on the plastic straw? Your guess that the plastic straw would carry a negative charge is correct. The electrical charges generated by rubbing are static. They do not move by themselves. When charges move, they constitute an electric current. You have been reading about electric current since class 6. The current in a circuit which makes a bulb glow or the current that makes a wire hot is nothing but a motion of charges. Transfer of charge. Take an empty jam bottle. Take a piece of cardboard slightly bigger in size than the mouth of the bottle. Pierce a hole in it so that a metal paper clip can be inserted. Open out the paper clip as shown in figure 12.4. Cut two strips of aluminium foil about 4 cm into 1 cm each. Hang them on the paper clip as shown. Insert the paper clip in the cardboard lid so that it is perpendicular to it. Charge a refill and touch it with the end of the paper clip. Observe what happens. Is there any effect on the foil strips? Do they repel each other or attract each other? Now touch other charged bodies with the end of the paper clip. Do foil strips behave in the same way in all cases? Can this apparatus be used to detect whether a body is charged or not? Can you explain why the foil strips repel each other? The aluminium foil strips receive the same charge from the charged refill through the paper clip. Remember that metals are good conductors of electricity. The strips carrying similar charges repel each other and they become wide open. Such a device can be used to test whether an object is carrying charge or not. This device is known as electroscope. Thus, we find that electrical charge can be transferred from a charged object to another through a metal conductor. Touch the end of the paper clip gently with hand and you will find a change in the foil strips. They come back to their original state. Repeat charging of foil strips and touching the paper clip. Every time you will find that the foil strips collapse as soon as you touch the paper clip with hand. Why does it happen? The reason is that the foil strips lose charge to the earth through your body. We say that the foil strips are discharged. The process of transferring of charge from a charged object to the earth is called earthing. Earthing is provided in buildings to protect us from electrical shocks due to any leakage of electric current. The story of lightning. It is now possible to explain lightning in terms of the charges produced by rubbing. You learnt in class 7 that during the development of a thunderstorm, the air currents move upward while the water droplets move downward. These vigorous movements cause separation of charges. By a process not yet completely understood, the positive charges collect near the upper edges of the clouds and the negative charges accumulate near the lower edges. There is accumulation of positive charges near the ground also. When the magnitude of the accumulated charges become very large, the air, which is normally a poor conductor of electricity, is no longer able to resist their flow. Negative and positive charges meet, producing streaks of bright light and sound. We see streaks of lightning. The process is called an electric discharge. The process of electric discharge can occur between two or more clouds or between clouds and the earth. Today we need not get frightened by lightning like our ancestors did. Now we understand the basic phenomenon. Scientists are trying hard to improve this understanding. However, lightning strike could destroy life and property. It is therefore necessary to take measures to protect ourselves. Lightning safety. During lightning and thunderstorm, no open place is safe. Hearing thunder is an alert to rush to a safer place. After hearing the last thunder, wait for some time before coming out of the safe place. Finding a safe place. A house or a building is a safe place. If you are traveling by car or by bus, you are safe inside which windows and doors of the vehicle shut. Do's and don'ts during a thunderstorm. Outside. Open vehicles like motorbikes, tractors, construction machinery, open cars are not safe. Open fields, tall trees, shelters and parks, elevated places do not protect us from lightning strokes. Carrying an umbrella is not at all a good idea during thunderstorms. If in a forest, take shelter under shorter trees. If no shelter is available and you are in an open field, stay away from all trees. Stay away from poles or other metal objects. Do not lie on the ground. Instead, squat low on the ground. Place your hands on your knees with your head between the hands. Figure 12.6. This position will make you the smallest target to be struck. Inside the house, lightning can strike telephone cords, electrical wires, and metal pipes. Do you remember lightning is an electrical discharge? During a thunderstorm, contact with these should be avoided. It is safer to use mobile phones and cordless phones. However, it is not wise to call up a person who is receiving your phone through a wired phone. Bathing should be avoided during thunderstorms to avoid contact with running water. Electrical appliances like computers, TVs, etc. should be unplugged. Electrical lights can remain on. They do not cause any harm. Lightning conductors. Lightning conductors is a device used to protect buildings from the effect of lightning. A metallic rod taller than the building is installed in the walls of the building during its construction. One end of the rod is kept out in the air and the other is buried deep in the ground. The rod provides easy route for the transfer of electric charge to the ground. The metal columns used during construction, electrical wires and water pipes in the buildings also protect us to an extent, but do not touch them during a thunderstorm. So this was the reading of part 1 of our chapter 12, Some Natural Phenomenon. If you have any doubt or query, you can ask me in the comment section below. Also, you can find the links to the other parts and other chapters in the description box below. Thank you everyone.